All right, this is Pre-Calculus V, Unit 2, Lesson 5, Graphing Transformations of Trigonometric Functions. So in this video, I'm going to focus mostly on if you're given a trig function, can you find some of the important things like what is the amplitude, what is the period, what are the zeros, where are the asymptotes, okay? So let's take an example. Let's start with sine function. So let's say we have y equals 5 sine 2x plus 3. Okay, I'll even put in a minus 4, although I think the lesson left out vertical shift. Okay, and in fact, let's not, because that'll impact the zeros, and I want to be able to find those as well. Okay. I have one thing I like to do, one thing I prefer to do. I prefer to write this like this, 5 sine, and I factor a 2 out of 2x and 3. So this is x plus 3/2. And the reason is now I can read the phase shift directly on the problem here. So if you're asked the amplitude, the amplitude is 5, right there. Okay. If you're asked the period, okay, now the period is normally 2 pi, right? But you're taking and dividing it by 2. So the period is 2 pi divided by 2, or pi. Okay, remember it's division. It's when you multiply x by something, you're actually dividing the normal period by that number. And the phase shift is 3/2. So I read it directly from that. They did b over a or c over a or something like that. And that's fine. But if you think of it as factoring out the a and leaving it in this form, you can read it straight from there. Now it's 3/2, it's oppositesville and xville, so it's 3/2 left. It's been shifted left by 3/2. Okay, zeros. Well, the zeros of pi, or zeros of sine, are at multiples, at 0 and pi and 2 pi, multiples of pi, right? So the question is, where does 2x plus 3 equal 0 or n pi, any multiple of pi? I'm going to solve for x here, and 2x equals n pi minus 3, and x equals n pi minus 3 over 2, right? And anywhere that this is, any multiple of pi over 2, basically. So if I rewrite this here, it's negative 3/2 plus any multiple of pi over 2. Any multiple of pi over 2 is where the zeros are. Okay, so hopefully that makes sense. Let's try it now for another trig function. How about tangent? Okay, so let's say we've got tangent of, or let's say y equals 5 tan 3x minus 6, 3x minus 5. Let's do that. Okay? And remember, again, I prefer to think of factoring the 3 out. 5 tan 3x minus 5/3. Okay? And now we can't really talk about amplitude because tangent has no amplitude. It's infinitely tall, but it's stretched by a factor of 5. Okay, the period is naturally pi, right? For tangent. So the period of this function is pi divided by 3, because this is the division factor when you multiply x. Okay, and the phase shift is 5/3. Now remember, it's oppositesville, it's minus 5/3, so this is 5/3 to the right. Okay, and zeros occur wherever 3x minus 5 equals, now for tangent it occurs at multiples of pi, n pi, right? And I'm going to leave it like that. The asymptotes, they occur at multiples of pi over 2 plus multiples of pi. So where is 3x minus 5 equal to pi over 2 plus n pi? Okay, and we would solve for x and get results that way. Okay, so hopefully that makes sense. Well, let's throw in some specific examples here. So where specifically do the zeros occur? All right. If I solve for x, I get 3x equals n pi plus pi over 2 plus 5. Divide by 3, we get n pi over 3 plus pi over 6 plus 5. And so we're going to just let n be some things. Let n equals 0. Then this becomes 0 plus pi over 6 plus 5. So the 0 occurs at, okay, x equals 0 occurs at 5 plus pi over 6. Okay, and when n equals 1, we get pi over 3 plus pi over 6, which is 2 pi over 6 plus pi over 6, which is 3 pi over 6, which is pi over 2 plus 5. So 5 plus pi over 2. Let n be 2. We get 2 pi over 3 plus pi over 6. So 2 pi, that becomes 4 pi over 6 plus pi over 6, which is 5 pi over 6. So 5 plus 5 pi over 6. You get the idea. We can generate all these zeros for the trig function that way. All right, so hopefully that helps. Let me know if you need any other assistance.